This video is about how we can turn improper fractions into partial fractions. So first let's remind ourselves what an improper fraction is. Both of these examples are improper fractions because the highest power on the numerator, which is called the order, is equal to or bigger than the order of the denominator. So in this first example, the order of the numerator is 3. The order of the denominator is 2. So because 3 is bigger than 2, this is an improper fraction. Whereas with the second example, the order of the numerator is 2. The order of the denominator, if I were to expand this out, I'd have an x squared. So the order of the denominator is also 2. Therefore, this is also an improper fraction. So that's what an improper fraction is. Let's see how we can now turn this into its partial fractions. Okay, so I've got the 3x squared minus 3x minus 2, all divided by x minus 1 times x minus 2. Now I'm going to do some algebraic division with this. So in order so I know how to divide this, I'm first going to expand the denominator, so I know actually what I'm dividing by. So I've just expanded those brackets. So I know I'm dividing 3x squared minus 3x minus 2, and I'm dividing that by x squared minus 3x plus 2. Okay, so let's do this. So x squared into the 3x squared goes 3 times. I'm now going to do 3 times the x squared, 3 times the minus 3, and 3 times the 2. I am now going to take those away. So 3x squared take away 3x squared is 0. The minus 3x minus 9x. So minus 3x minus 9x will be plus 6x. And the minus 2 minus the 6 will be minus 8. Right, I would then carry on dividing, if I can. So I would then be looking, can the x squared go into the 6x? And obviously it can't. X squared does not go into 6x. So this is my remainder. So 3 is what's called the quotient. That's the whole part that I've got here. And the 6x minus 8 is the remainder. So I can rewrite this improper fraction as 3 plus the remainder 6x minus 8 that still needs to be divided by that denominator. Okay, right, let me just clear this so I've got some more space. It's at this stage where we're going to split up our second, the 6x minus 8 over the x minus 1, x minus 2. This is what we need to split up into our partial fractions. I'm going to ignore the 3 at the front here completely for now. I'm just going to focus on the 6x minus 8 over x minus 1, x minus 2. So I'm going to say 6x minus 8 over x minus 1, x minus 2 equals a something over x minus 1 plus something over x minus 2. And I'm now going to follow the same procedures like we have in the previous videos to work out what a and b are. So 6x minus 8 equals a times minus 2 plus b times x minus 1. I'm going to say let x equals 2. That way this will be 0 and I don't need to worry about the a term. So 6 times 2 minus 8 would be 4. Then I would have b times 2 minus 1. So I've figured out here that b must be 4. Right, now let's work out what a is. So let's now say that x is equal to 1. That way, if I say x is equal to 1, this will be 0, that will get rid of the b part and I can focus solely on the a part, which is what I'm trying to work out here. So let x equal 1. 6 times 1 minus 8 is minus 2. A times 1 minus 2 will be minus a. Therefore, a equals 2. So I can now replace this a with a 2. Right, let's put all of this together then. So by doing the algebraic long division, that allowed me to rewrite my improper fraction as 3 plus 6x minus 8. And I have just turned that 6x minus 8, I've just split that up into its partial fractions. So overall then, I can replace that improper fraction with the 3 plus the 2 over x minus 1 plus the 4 over x minus 2. And there we go.